Alright, so for problem 21, we can construct a set of all the odd numbers. So this has 10 elements, and now we notice that if we add any more numbers, it's an even number, so that means that the condition will not be met. Next, for problem 22, there's an interesting theorem called Descartes' circle theorem, which says that K4 equals K1 plus K2 plus K3 plus minus 2 root K1 K2 plus K1 K3 plus K2 K3, where the K's are the inverse of the radii, and the radii are 1, 2, 3, and let's call it x. And the reason it's plus minus is because the other possibility for the circle is this one. So now we can solve for K4. K4 equals 1 plus a half plus a third plus minus 2 times the square root of half plus a third plus a sixth, which is equal to 11 over 6 plus minus 2. We want the smaller circle, so the inverse is larger, so we take the plus sign, which is 23 over 6. So we take the inverse, r is 6 over 23. So this theorem made this question pretty trivial. It was just plug and mash. Next, we have a more interesting geometry problem. So let's draw a good diagram. Let's call this D, where these are equal, and let's call this E. So we know that this is 80, 45, and then 75. So by the angle bisector, we can find that this is 27, and this is 48. And now we notice that 27 over 45 is equal to 45 over 75. So this means that triangles CDB and CBA are similar. So that means that this angle is also equal to this angle. So we have BD equals 48. Next, we have AE, let's call it X, and then BE Y. So by Pythagorean, we have 75 squared minus X squared equals 45 squared minus Y squared. So 30 times 120 is equal to X minus Y and X plus Y. X plus Y is just 80, so we can sub that in. So we find that X minus Y is equal to 45. So now we have two equations, so we can just solve. We have X equals 125 over 2, and then Y equals 35 over 2. Now we can use a cool trick called mass points, which is basically assigning masses to find ratios of side lengths. This is a concept that probably originated from physics because it has the idea of balancing. So we notice that X over Y can be simplified. To 25 over 7. So we can assign this to be 32, 25, 7, and then 48 over 27 can be simplified to 16 over 9. So we have this should be 16 relatively, this should be 9, and this should be 25. Right. So that means that this point should receive a value of 7 times 25 over 9. And then this value doesn't really matter. So now we want BP. So we have BP over BD. BP over BD is 7 times 25 over 9 over 25 times 16 over 9, which is 7 over 16. And then BD is 48, so BP is 21. So the answer is D. Now next, for problem 24, this is a cool counting problem. So we can just focus on the largest number, because for it to be fair, the numbers kind of need to go like this, where there's a peak. So let's consider the number of the peak. So let's say it's 5 as an example. Then that means that the digits from 6 to 9 cannot be used. So now we just consider 0, 1, 2, 3, and 4. Sorry, zeros cannot be used. So just 1, 2, 3, 4. Each of these integers can go here, here, or nowhere. So there's 3 choices for each. And that guarantees a unique integer, because let's say 1 and 2 go here, 4 goes here, and 3 doesn't go anywhere. Then 1 and 2 have exactly one ordering, which is strictly increasing. So now if we just extend this argument for all possible values of the peak, we have sum of I equals 1 to 9 of 3 times I minus 1, which is 1 plus 3 plus all the way to 3 to the 8, which is 3 to the 9 minus 1 over 3 minus 1 by geometric series. Now we can just calculate this. So we know that 3 to the 6 is 729, so we can multiply this by 27. Now 16182 divided by 2, we get 8, 0. Add this instead. There we go. That looks more like it. So this divided by 2 is 9. 8, 4, 1. So it's C. There we go. just a lot of calculations. All right, this is a really interesting problem. So problem 25, it's geometric probability. So let's draw a square. All right, so it's probability once again. So we can just let the side lengths be 1. So we don't want AP to be the shortest. So we can draw equilateral triangle. Also a circle. So P is only the shortest if AP is less than BP and AP is less than AB. So AP is less than BP if it's in this rectangle, and AP is less than AB if it's here. So this is something we don't want. Something else we don't want is to be the longest, so it should be in this quadrant, and then it should be outside. So this is also what we don't want. So now we're looking for the rest of the area. So this area is equal to a 60-degree sector, so 1/6 of pi minus this right here. So this is a half, and this is a √3/2. So minus √3/8. And this area here is 1/2, which is this rectangle, minus this sector, which is a 30-degree this time, so it's pi/12. And then minus this triangle again, which is √3/8. So it's pi/12 plus 1/2 minus √3/4. So now we can take the GCD, so it is 6 plus pi minus 3√3/12. So A equals 6, B equals 1, C equals 3, D equals 3, E equals 12. So the answer is 25.